So initially this particle is hanging beneath O, elastic spring of natural length 0.7, and it's hanging a bit below that in equilibrium. And normally I have that being x, but this time it's x below the equilibrium later on, so I'm going to call that y. Put my forces in, that's going to be 0.2 g, and that's going to be tension, and that is the lambda, which in this case is, well, I'll put lambda times the extension, which is y over natural length L, which in this case is 3.5 y over 0.7. And for equilibrium, so equilibrium, then the upward force equals the downward force, and we get 3.5 y over 0.7 equals 0.2 g, and so y equals 0.2 g times by 0.7 all over 3.5, and so y equals 0.392, and show that the equation is 1.092. That's only 0.392. I need to add it to the 0.7 because that's O there. Therefore, 1.092 below O. And that's done the first bit. Now the second bit I'm going to do up here, part 2, I'm going to prove it moves with simple harmonic motion, and I've got to calculate the amplitude. So this one I'm going to draw it again. So it's hanging below O. Elastic cord, and it's got the natural length is 0.7. It's stretched on below that, so we always can do it from the equilibrium as another 0.392, and now it's going x below. I put a single-headed arrow in there for x because that tells me that's going to be positive, and so I'm going to put the acceleration in x double dot going straight down. And now I can do the forces. I've got down here again 0.2 g. Going up, I've got tension, which equals lambda times the extension, which will be in this case 0.392 plus the x all over L. And now we can do this one, and we're going to have to resolve. I'm going to resolve downwards because that's the way I've decided it's going to be positive. And as always with almost all mechanics, resultant force is mass times acceleration. So we're going straight down. What have I got? I've got the 0.2 g. I've got minus, because it goes up, this tension here, lambda, which is 3.5. So 3.5 times by 0.392 plus x, because that's the total extension, all over L, which was 0.7, and that equals the mass, which is 0.2, and the acceleration is x double dot, and that's going to give me, I'll bring it down here, so I have a bit more space, 1.96 minus 3.5 times by 0.392 divided by 0.7 is minus 1.96. That's always going to happen. And then we've got minus 3.5 divided by 0.7, that's minus 5x, and that equals 0.2 x double dots. And so therefore x double dots equals times both sides by 5 minus 25x, and therefore that's n squared. Therefore n equals 5, and we have simple harmonic motion with period 2 pi over n, which is 5. And so the equilibrium position is projected down with a speed of 1.6 meters per second. And so we know what velocity equals. That's when the extension is 0, so that's from at that point it's projected down. It's projected from the equilibrium, so we've got from the center, so therefore we can use sine, and so we've got x equals a sine and n is 5t. So we've got that, but we've also got the Nax formula, because we want to work out the amplitude. That's going to be hard to work out because we don't know too much about that, but we know that v squared equals n squared, which we know, times a squared, which we want to find, minus x squared. And we know that the maximum velocity is when the extension from the equilibrium is 0, and that's 1.6. So we get 1.6 squared equals 5 squared times by a squared minus 0, because maximum velocity is say when that x is 0, and that gives us that a squared equals 0.1024, and so a equals 0.32, and that does the second bit. That's the amplitude. And the third bit I will do down here, and we get calculate x and v when t equals 0.04. Well, I would use our formula here, and we get x equals a, which just worked out 0.32 sine of 5t, and when t equals 0.4, x equals 0.32 times by sine of 5 times that, which is 2, and that equals 0.290975. And then we want to find also what the velocity. We've done x, we need to find v, and we know that's v equals x dot, which equals 0.32 times by 5, which is 1.6. Differentiate sine, we get cos 5t, and when t equals 0.4, v equals 1.6 cos 2, which equals negative 0.6658349, etc. And that does that. I'll do in purple another way you could do it. You could of course use the Nax formula, and we could do it like this. We get v squared equals n squared, which is 5 squared. We've worked times a squared, which is 0.32 squared, take away, and x squared. And we've worked out here what x is, so we can substitute x in to there as 0.29, and it gives us v squared equals 0.443338.7. And now we have to square root it, and when we square root this, we're going to get plus or minus. So we're going to get plus or minus 0.6658, etc. Same numbers we've got here. Which one do we choose? Well, the period, 2 pi over 5, is 1.2566, and that means it's got to go down to the bottom, back up to the top, and back down here. So this bit here is 1/4 of that, and 1/4 of the period is 1/4 of 1.2566, and that equals 0.314. And therefore it's going to be, we want to get it when t is 0.4, so that means it's not going down anymore, it's going up, and therefore the velocity is minus 0.6658, therefore it's upwards. And that's question 4 done.